All right, today we're going to talk about solving one-step inequalities with just addition and subtraction. So the good news is that if you know how to solve equations, you also know how to solve inequalities. All of the steps are exactly the same. The difference is that we will need to graph our answer on a number line. So for example number 1, we're going to ask ourselves what's happening to the variable. It's being added to 7, so we're going to do the opposite operation. The opposite of adding 7 is subtracting 7. And whatever we do to one side of the inequality, we have to do to the other side, just like an equation. So we'll bring the x down. 7 minus 7, of course, is 0. And I don't know why it's jumping. 13 minus 7 is 6. So that's my answer. Your answer for an inequality has two parts. It has the inequality, like you see there, and then we're also going to graph it on the number line. So I'm going to put my 6 on my number line, and like I told you in the last lesson, I just like to count by ones from there. I'm going to do an open circle. Let me change the color here. I'm going to do an open circle on the 6. I'm going to point to the right to show all the numbers greater than 6. For the next inequality, I have x minus 8 is less than negative 19. Since x is being subtracted by 8, the opposite would be to add 8 to both sides. Bring down the x. Negative 8 plus 8 is 0, and then negative 19 plus 8 is negative 11. On my number line, I'm going to make sure I have a negative 11. I'm going to count from there. Negative 12. It's so hard to squeeze it in there. I'm going to do an open circle because there's no line underneath the symbol on the negative 11, and I want to show all the numbers less than negative 11. For example number 3, I have x plus 6 is greater than or equal to negative 21. The opposite of adding 6 is subtracting 6. Bring down my x. 6 minus 6 is 0. Keep my symbol. Negative 21 minus 6 is negative 27. So I need to have a negative 27 here on my number line. And this time I'm going to do a closed circle on the negative 27 because I have this line underneath my inequality, which means that it's all the numbers that are greater than or equal to negative 27. So since it includes negative 27, I'm shading it in, and all the numbers greater than negative 27 are to the right. And my last example, you might notice, looks a little bit different because the variable is on the right-hand side. And so we've talked a lot about how having the variable on the left side just looks better to us, but now it becomes very important to have it on the left. So here's how you can just start by rewriting it by putting the x minus 5 over here and the 11 on the right. The tricky part is that since this symbol is telling us that 11 is less than x minus 5, we still need to show that 11 is less than x minus 5, which means I'm flipping that symbol over, right? Because I want the x minus 5 part to be greater than the 11 part. All right, once I've done that, I can solve by doing the opposite operation to each side, the inverse operation, which is to add 5. So I have x is greater than 16. And then I'm going to do an open circle on my 16 because there's no line underneath my symbol. And then we are pointing to the right to show all of the numbers greater than 16. So remember how I said that it's important to have the variable on the left? This is how come. If the variable is on the left, your answer is this, right? But it's also your number line, and the arrow on your number line will go in the same direction as your inequality. See how this is the same direction as your arrow, this is the same direction as your arrow, this is the same, oops, that's not the answer, but still works. Where's my undo? This is the same direction as your arrow. So that only works if your variable's on the left. Another reason why it's important to write your answer with the variable on the left. Thanks for watching.